How's it going, students? In this video, I wanted to go over a few concepts as it relates to our position and time graph gizmos. So when we first look at the graph, it's important for us to recognize what are we looking at. So do you remember what this horizontal axis is called? Okay. It is called your x-axis. And the x-axis, when we're talking about experiments, the x-axis is your independent variable. This is where the independent variable information goes. When we're talking about physics concepts, how things move, the x-axis is typically time. So the time is going to be at the bottom. Notice the x-axis is labeled time. And then let's take a look at our y-axis. Our y-axis is distance. Now this is known as a position and time graph. Sometimes you'll see distance, sometimes you'll see position, but this is a position and time graph. Now, what we see here is a runner. We'll call him runner one. And notice as the time changes, what happens to the distance? So at 1 second, the athlete is at 10 meters, 2 seconds, 20, and so forth. Let me go ahead and animate that for you. So I'm going to click the start button. Notice at 1 second, the runner is at 10 meters. Okay. I'm pausing it here so you can kind of see what happens as time changes, the position changes. Okay. All right. I'm going to reset to show you the entire thing. So notice as time changes, the position or the distance increases. That is what's represented by this position and time graph. The next thing I wanted to show you is what is the difference between distance and displacement? So once again, I'm going to put this here. I'm going to start it. Now, my question to you is, how far did the runner travel? The runner traveled 40 meters. Let's try another example. All right. How far did the runner travel? The runner traveled 40 meters. Now, let me explain that. Person traveled, boom. How far did they travel? 20 meters. And notice this runner goes back. So 20 plus 20 is going to give you 40 meters. Now, here's where distance and displacement become different. Displacement is where are you from where you started. So this runner started at 0 meters. And where is it at the end of the journey? It's at 0 meters. So this means the displacement is going to be 0. Let's do another example. Let's go all the way over here. Okay, so at 2 seconds, how far did this runner travel? 20 meters, right? Person started here, they traveled all the way to 20 meters. Now, at this moment, What is the displacement? The displacement is also 20 meters. The reason why this is because the runner is 20 meters away from where it started. So remember, the difference between distance and displacement. Displacement is where are you from where you started. Distance is simply how far did you travel. It doesn't matter the direction. It's just how long was the trip? How far did you travel? In this next section, I want to talk to you about how you can calculate speed using a position and time graph. So let's take a look here. Remember that speed is distance divided by time. Let's take a look at this example. The runner travels how many meters? What's the distance? This is 40 meters, right? So this runner travels 40 meters. And how long did it take? Let's take a look at our graph here. 4 seconds. Speed is distance divided by time. So 40 divided by 4 is going to give us 10 meters per second. In this next section, I wanted to go over a velocity and time graph. So in the Gizmos, when you click the top here, you can see not a position and time graph, but a velocity and time graph. And this is important because when you are looking at graphs, you need to identify what is the graph giving you? What information are you receiving from this graph? So you need to take a look at your x-axis. Now we can see that the x-axis is labeled in time. And our y-axis is velocity. And notice it's meters per second. Remember, we learned previously about the difference between distance and displacement. So let's take a look at how to identify what information is given on a velocity and time graph and how that's different than a position and time graph. So this graph that's shown on the left is our velocity and time graph. And the graph that's shown on the right is our position and time graph, or distance and time graph. This graph represents the same event. So let's take a look at that. Let's restart our timer. And let's click here. Notice the differences between these two graphs. Our position and time graph, notice as time changes, the distance changes or the position changes. However, take a look at our velocity and time graph. Notice the velocity and time graph. What do you notice about the slope? What do you notice about the slope? The slope is flat, okay? So on a velocity and time graph, if the slope is flat, what does that mean? If there is a flat line on a velocity and time graph, that means that object is moving at a constant speed. Now, if you see a flat line on a position and time graph, what does that mean? So a flat line on a position and time graph, let's go ahead and play that. Let's see what happens. So on a position and time graph, a flat line means that object has no motion. Let's watch that again. Pausing for about a second and then continuing on the path. Let's see that information on a velocity and time graph. Notice what happens to the velocity. It drops right down to 0. Now it's still a flat line, but it's very important to remember the difference. A flat line on a velocity in time graph doesn't necessarily mean no motion. It depends on the amount. So you take a look at the y-axis. If the velocity is 0 and it stays at 0, then of course we know if an object has no velocity, then it's not moving. So let's watch that together. Notice it's not moving, and then it continues, right? So it's very important to remember the difference. On a position and time graph, a flat line means no motion. On a velocity and time graph, a flat line means constant speed unless the object on the y-axis, the object is at a velocity of 0. If it has 0 velocity, then that means it has no motion. In this next section, I want to talk to you about negative velocity. Let's take a look at this example. Notice the object, or the person here, is running at a constant speed, and then notice what happens. Right as the athlete reaches the 30-meter mark, notice what happens to the velocity. Do we see that? The velocity dropped down to a negative number. And that is because, remember, the difference between speed and velocity is velocity deals with direction. In this graph, the direction for velocity is moving, increasing the distance, right? 10 meters, 20 meters, 30 meters. But if the object goes in the opposite direction, that object will now have negative velocity. Now, this is different than speed because you can't have negative speed. You can't go back in time, right? So velocity can be a negative number if you are going backwards, if you're going the opposite direction.